In this video, we're going to go over the basics of sequence loops and logic. The first spot we'll want to look is in the step configuration editor. To access this, right-click on a step and select Configure Step. Here we can define the step behavior. If wait for confirmation is enabled, the sequence will not continue until Enter is pressed. Displaying a step when run will actually show us the step when it is run, and we can define a time in seconds for how long it is displayed to us. We can also display the step only when it fails. We can set the steps to halt on fail or halt on pass. This will just stop the sequence if those conditions are met. Alternatively, we can set the step to jump on either pass or fail. If this is enabled, the drop-down to the right will show us every other step in the sequence. Using these features, we can set different loops or if-then statements within SoundCheck. If a loop is set with jump on pass or fail, we can enable the loop index, where after n amount of repetitions, we jump to a different step regardless if it passes or fails. The name of this loop index can be defined, units can be assigned, and it will enter the memory list. This value can be used in different ways throughout the sequence, which we'll explore in some of our examples. At the bottom, overwrite data or keep repeated data has a major effect on what happens in a loop. If we configured a sequence to loop and a step runs multiple times, overwrite data will always output one piece of data, while keep repeated data will append the loop index name to the data that's output and keep every iteration that's run. Here's an example of a sequence where we have step logic configured. Clicking on the plus sign next to the step name will display the configuration of that step. Step 6, which is highlighted at the top, shows that it will jump on pass to step number 7, and on a fail it will jump to step 15. We follow this logic down after step 7, and we get to step 14. If this step passes, it jumps to 7, or jump on fail to step 15, which will complete our sequence. On this step, the loop index is also enabled. After 100 loops, regardless if step 14 passes or fails, it will always jump to step 15. I've mentioned steps passing or failing, so let's take a look at some specific examples of that in SoundCheck. One type of step that will output a pass or fail is a limit step. Message steps will also output a pass or fail. We can use a dialog message step, which will ask a user a yes or no question. Message steps are also used for reading digital I/O inputs. We can read specific bits, and if those bits match, the step will pass, and if they don't, the step will fail. Display steps can also act as an overall pass-fail logic for multiple results. If we displayed 5 limit steps, for example, on a display, if any of those failed, the display would fail, but if all of them passed, the display would pass. Custom steps can also be written to pass or fail. Let's open up SoundCheck and look at how we could implement this. I have a basic sequence here. It will sweep, get a fundamental, take the sensitivity at 1 kHz, apply a limit to that sensitivity, and then display it. And the first thing I want to point out is steps 5 and 6 are highlighted in green. Steps that pass are highlighted in green, steps that fail are highlighted in red. The max sensitivity was set to 100, mine was 83, so it passed, and there's only one limit on this display, so the display also passed. Now I'm going to enter in an operator dialog message at the beginning of the sequence. I'll double-click it to ask if it wants to pass. Now when I run the sequence, if I click yes, it will be highlighted in green and pass, and if I click no, it will be highlighted in red and fail. The last type of step we can give a pass and fail on is a custom step. I'm going to drag in the system custom step, which is included with SoundCheck. This step will run the command that I write here through the command line, and if it properly executes, it will pass, and if it does not properly execute, it will fail. Just as a really simple example, I'll open the calculator, actually drag the calculator onto the screen, and the step passes. If I open this again and put in a typo, it will attempt to call this command, the command won't exist, and you can see it will throw back a failure. Now I want to actually add some logic to my sequence, so I'll right-click on this message step and select Configure Step. Right now, the only thing that's enabled is it will display when run. Now I'll also enable halt on fail. I run the sequence, and when I click no, the step fails and the entire sequence stops running. I run it again, press yes, and the entire sequence runs. If I turn off halt on fail and enable halt on pass, I click start, hit yes, the step passes, and now it completely stops again. But let's say I wanted to add some more logic to my jumps now. Instead of simply stopping, I want to go to different parts of my sequence. Now we'll take a look at this limit step. I'll enable jump on pass, and when I click on this dropdown, you can see every other step available in the sequence. So I'll configure this to jump on pass to the final display, and jump on fail to the beginning of the sequence again. You can see everything involved in the loop gets indented. I'm going to change this loop so it won't actually ask me again if I want to run the test and jump back only to the acquisition step to play the sweep again. When I do that, you can see the indentation changes. Steps 1 and 2 are no longer part of the loop, so they're no longer indented. I'll run the sequence, the limit step passes, and nothing actually looped. I'm going to just change the limit step to 60. My sensitivity is about 80, so we know this will fail. I run the test, and what happens now? Basically, I get stuck in this loop forever. I'll go over here and manually abort the sequence. I'll go back into this limit step and change it so it's borderline. Something like 82 will be a little bit closer. After the loop fails a couple times, I'm just going to physically take my microphone and move it so it passes. Now you can see this limit passed, it jumped out of the loop, and finally displayed on our step. I'm going to go back into the configuration and enable the loop index. What I want to do is after 5 repetitions, no matter what, jump out of the loop and go to the display. One other thing I want to note here is this jump on pass being enabled is actually unnecessary. If the step passes, it will always go to the next step in the sequence by default. Since this display is the step exactly after my limit step, I don't need to enable this jump on pass. I'll put my microphone back where it was before so the sensitivity will fail. Now when I run the sequence, the limit step will fail. It will jump back to the acquisition step. But after 5 times of this happening, even though it still fails, it will jump out of the loop and finally display the data. Next, I'm going to add in another limit step. I'll take my fundamental and have the upper limit be plus 3 dB floating, and the lower limit be minus 3 dB floating. So basically we have a 6 dB window. I'll put the upper and lower limit here on the display, and I'll add the new result onto our display. I'm also going to edit the message step, so if we say no, the test won't run. So now our display step passing or failing is dependent on 2 limits. The single value step failed still, which is where our loop was configured, so we ran 5 times then jumped to the display. The curve limits did pass though. Every result that is displayed on the display step must pass for the display to pass. Now I'm going to change my logic a little bit. I no longer want to jump depending on this single limit. What I want to do is have a display that will jump to a different message step depending on if everything passed or if something failed. So I'll just add in a message step that says it passed. I'll rename it. And now this message step will be if something failed. And I'll rename it to failed. On my display step, I'll configure to jump on pass to the message that says it passed, and to jump on fail to the message to say it failed. I'm also going to change the wording on this message step, because again, it doesn't mean that everything failed, it means that at least one thing failed. But one thing we need to think of is that if we jump to the message that says passed, what will happen afterwards? it will continue on and then run to the failure message, so we need to adjust that. So to get around this, I'm just going to add in a dummy step at the end of the sequence that doesn't actually do anything. And I'll set this to no matter what happens, if this message step passes or fails, it will always just jump over the failure step and go to the dummy step. I'm also going to turn off wait for confirmation and have these steps just be displayed for 3 seconds before jumping. I run the sequence and one limit still fails, so my display step fails. It completely jumps over the pass step and then goes to the failure step. Once this failure step runs, it goes to the dummy step. We actually don't want anything to show up here at this dummy step, so I'm going to change this configuration to not display when run and not require confirmation. I want everything to pass, so I'll just go into my limit step and change the upper limit. Now I run the sequence. Both limit step passes, so the display passes. It goes to the message step that tells me everything passed. After 3 seconds of displaying, it jumps to the dummy step and the sequence is complete. I'm going to back out the changes I made to the sequence, and we'll take a look at overwrite versus keep repeated data. I'll just run the sequence to put data in the memory list. I'm going to the display step, and I'm going to make a loop. Regardless if it passes or fails, we're going to jump back up to the play and record step, and then after 3 repetitions, the loop will end. I run the sequence, and the loop happens 3 times. I'm not making any changes to my setup, so the curve looks about the same as it runs. Now let me open the memory list and say I wanted to find all of that data. I'm only seeing 1 fundamental in here, even though it ran 3 times. If I expand the analysis step configuration, which outputs the fundamental, you can see it's set to overwrite curves. What this does is every time it loops, it will just take the fundamental and overwrite anything also named fundamental. We ran this step 3 times, but it always overwrote the previous run. That's the same for every other step in the sequence. So if I go up here and change this acquisition step, instead of one item in the waveform tab called recorded time waveform, it will keep all the repeated data. So I run this test once, I jump back 3 times, so it prepends a number, which is the loop index, to the beginning of the data name. The problem with setting it up this way is every time I run my analysis, I would need to point to the correct recorded time waveform. In this example, I don't really care about saving the waveforms, I just want to save what happens afterwards. But I'll set this step to keep the repeated data. So it will run once, the acquisition will output recorded time waveform, and then it will give me my first fundamental called 0 fundamental. The loop will run again, it will overwrite recorded time waveform, the analysis step is still looking at that waveform, but when I run the analysis step again, it will now give me 1 fundamental. So I'll display all 4 of those here on this graph. Now I'll set the post-processing and limit step to also keep repeated data. Over in the values in the results tab, we can see all of these new pieces of data getting output. I run the sequence again and it loops. It's kind of hard to see because of how similar these fundamentals are. So I'll just change the color and overlay them. Each of these pieces of data is now saved. The names of the data that is repeated is dependent on the loop index. You can see it's prepended by 0, then goes to 1, 2, and 3. And opening my step up, we can see it starts at 0 and increments by 1. I can change this to whatever I want. So if I started at 5 and incremented by 3, you can see all of my data names would change. My first fundamental starts at 5, then each one afterward would increment by 3. I'll run this sequence one more time, and I'll actually pick my microphone up and move it around so we can see the difference between these tests. So now in the final display, we see fundamentals 5, 8, 11, and 14.